Today we're going to use Maple to explore inverse functions. Inverse functions are functions which basically reverse one another. If you have two inverse functions, f and g, and you take their composition, so you take f of g of x or g of f of x, then you should just get back your original input, or x. So let's define a function. We'll try to find its inverse. So I think we're going to use the function 3x plus 1 over x minus 2. So I define my function, f colon equals x goes to 3x plus 1 over x minus 2. Of course, I can evaluate it. Let's see what happens when I plug in 1. F of 1 is negative 4. You can check that by hand if you want. So to find the inverse function of f, you swap out the variables, x and y, and solve for y. So the way you do that in Maple is you say solve x equals f of y, and we're going to solve it for y. So we get 2x plus 1 over x minus 3. We may want to give it a name, so make it a function. So we define g colon equals, and we don't have to type the whole thing again. We can just use the unapply command, %, and we want our variable to be x. What unapply does is it takes an expression, in this case we're using % to reference the most recently evaluated expression, which is 2x plus 1 over x minus 3, and we say we want its variable to be x. And it returns the function x goes to 2x plus 1 over x minus 3. Notice if I now put in g of negative 4, I get 1. So it basically does the opposite of what f does. It reverses the x and the y coordinates. If you want to check that two functions are inverses, you would evaluate the function composition f of g and the function composition g of f. The function composition operator in Maple is the @ sign. So if I want f of g of x, I type f at g and pass it the argument x. Now, if these are supposed to be inverse functions, I should get just x back when I do that. So why is that not happening? And it's because Maple does not necessarily simplify automatically. So sometimes you have to explicitly tell it to simplify. So I type simplify f of g of x. Notice that the parentheses for the simplify command are around the entire composition. Be careful with parenthesis placement. And it does in fact return just x. If I take the composition in the other direction, so simplifying g of f of x, it also returns just x. Those two compositions, because they return x, tell us that f and g are inverse functions. The other thing we want to look at is how the graphs of inverse functions relate to each other. So let's look at the graphs of f and g. So we're going to plot f of x and g of x on the same coordinate system. And we're also going to plot the line y is equal to x. We're going to give it a legend. So the legend is going to show also f of x, g of x, and y equals x. And, while we're at it, we may as well give it a title. We'll call it Inverse Function Symmetry. And this one doesn't work particularly well unless we specify that x and y are scaled the same. So we're going to take x from negative 10 to 10 and y also from negative 10 to 10. And this is the graph we get. The original function f is shown in red, and its inverse function g is shown in blue. And these vertical lines are actually not part of the graph. They're actually showing the asymptotes of the graph. You see that the red function with denominator x minus 2 has an asymptote here, where it's undefined when x is 2. Similarly, the one with denominator x is 3 has an asymptote here, where x is 3. But what I want you to notice about this graph is if you look at these curves here and up here, you see that these two graphs are actually reflections of each other about the line y is equal to x, which is shown here in green. And that's the major property of the graphs of inverse functions. They're symmetric reflections of one another across the line y equals x. Do notice we'd get the same picture if we start with our function g and repeat the process. So I'm going to restart to clear all my function definitions. And I'm going to take f now to be the function that takes x to 2x plus 1 over x minus 3, which is what was our g of x that we got by finding the inverse function of 3x plus 1 over x minus 2 earlier. And I want to find its inverse function, so I'm going to solve x equals f of y for y, and lo and behold, I get back 3x plus 1 over x minus 2, which was the original function f. So that's another property of inverse functions. If g is the inverse of f, then f is also the inverse of g. So that's the basics of inverse functions using Maple.